All right, so this is the start of part 2. I'm just continuing on with the notes. So here in the diagram, BC is tangent to A. So that means, oh, there's no letters there. This is BC, by the way. This is a tangent. This is a radius. So if you look back at your notes, I'll even flip over to it. If you have a tangent and a radius put together, a right angle is formed. So we're going to end up using the Pythagorean theorem. That's what's different from the prior problem. We did not know it was a tangent. So here we do know, and I'm just going to mark it into color, totally up to you if you do, there is a right angle there. So as you can see, we're going to end up using the Pythagorean theorem for this. So this time we know it is a tangent. So we're going to use the Pythagorean theorem. Okay. So this will be my A. So that'll be r squared. That'll be my B. So that's easy so far. Sorry for the big numbers. I didn't realize that till after the fact, and it just is what it is. So then we need our C. So our hypotenuse isn't 16. This is 16. That's not my whole hypotenuse. My hypotenuse is this whole segment we have going on here. So if you're going to find the whole segment, we need to use what we used to. Part plus part equals the whole. So therefore, my C is r plus 16. Part plus part equals the whole. So we leave it as r plus 16. So therefore, over here, I'm going to put in parentheses r plus 16 squared. So this left side, super easy, other than the fact of 24 squared. Sorry, once again, if you have a calculator, you guys can quickly type that in. But it comes out to be 576. It's this other side that's tricky. You don't just distribute the square. That's really bad news, and that is not good math. You need to remember what it means to be something squared. So I'm going to put this off to the side. You do not have to write this down. But just kind of look real quick right here. If I gave you 5 squared, we all know that's 25. Well, that's because you're doing something times itself. Okay, giving you the 25. So now using that knowledge, going back up over here, if I have r plus 16 squared, that means to do r plus 16 times r plus 16. When you square something, that means to multiply something times itself. So this might look familiar to you. I'm going to use a color you don't need to. Foil. Hopefully that sounds familiar from Algebra 1 last year. You're going to need to FOIL this out. Okay, so that means first, outer, inner, last. You're going to end up having to multiply all that out. So now I'm going to pick back up my pencil. I'm just going to quickly write this down again. First, so r times r is r squared. Outer, 16r. Inner, 16r. Last, 16 times 16 is 256. So remember, first is how I got that. Outer is how I got that. Inner is how I got that one. And last, 16 times 16 gives me the 256. So I do need to simplify this side by adding these like terms that are right here. So I end up with r squared plus this 576, just kind of hanging around, equals r squared plus 32r plus 256. So the thing is, at first you're like, oh gosh, I got to deal with these r squareds. Well, you have to combine like terms. If I subtract r squared from both sides, take a look at what happens. They cancel out. So you are just left with 576 equals 32r plus 256. So you're left with something very easy. Next step is just to subtract my 256. I get 320 equals 32r. Divide by 32. 10. Ooh, sorry guys, I didn't notice that you couldn't see that. 10 equals my radius. Okay. This probably the hardest problem you're going to get all semester. They are all done the same way. There is one in your homework. So when you get to the one in your homework that's like this, I think there's one, maybe two, just rewatch this part. It happens where you're going to end up having a whole piece. You're going to end up having a FOIL. The R squareds will cancel out, and then it's just basic from there. Okay, so make sure you refer to this problem when you come to that. So let's do a few easier ones. This one, super easy. I told you, look out for this type of diagram. If you actually look back in your notes, this one looks like this. When you have the two tangents, they're just congruent. That's the theorem. So if you take a look right here, all that means is these are now congruent. And if things are congruent, set them equal. So I have 26 equals 2x plus 4. Subtract the 4. I get 22 equals 2x. 11 equals x. Basic, nothing fancy. This one, all right. So a couple of things that I kind of left off of the diagram, and because I'm at home and I can't use the program. This is our center of our circle. Okay, so we can't assume that. We can't assume this is a radius and that is the center. So the nice easy one to find out of y, z, and w is y. The reason why, this is a radius, this is a radius. If they're both a radius, then they're going to be equal. If this one's 15, this one has to be 15. So we know y equals 15. Because this is a radius, that's a radius. That should be something that you should remember from middle school. Z is also something also pretty easy to find. Or excuse me, Z. It kind of reminds you from the prior problem up here where you've got the two tangent and the common points. So over here we got the two tangent and the common point. So therefore if this one's 36, this one's 36. So Z equals 36. All right. Now W gets a little harder. W gets a little harder. What we have here, this is a radius. Remember, this is a radius. This is a tangent. A radius and a tangent forms a right angle. So what we end up having is, I'm going to highlight it. You don't need to unless you want to. Is a right triangle. A radius and a tangent makes a right angle. We got ourselves a right triangle. So therefore, use the Pythagorean theorem. So to find to find W, use Pythagorean theorem. So we're going to just do, once again, I apologize for these big numbers, 15 squared plus 36 squared equals W squared, just because, these are easy numbers and time purposes. I don't want you guys spending too much time on this. This is 225 plus, oh goodness, 1,296. This would be a calculator if I ever gave you this. These added together, 1,521. From here, remember, take the square root, plug it into our calculator, 39 equals W. So that is 10.1. So if you need help with any of these, like I said, this chapter 10 in your textbook, has all sorts of examples just like this. So please refer to 10.1 in your textbook for more examples about this. But in the meantime, we are actually going to move on to 10.2, which is even easier than 10.1. So go ahead, if you want to, go ahead and pause the video. Copy down everything I kind of filled in. It just is a little easier if you just copy this down first. So pause the video, copy it in, all the missing blanks, and then I will go through it. So go ahead and pause it. So here we have, we're going to talk about arcs. So we have what's called a central angle. A central angle of a circle is an angle whose vertex is at the center of the circle. So in a color, so pick up any color, we have our central angle. This is my central angle. So angle ACB is a central angle. Okay, so it's at the center. So with this, you can kind of tell if I start making a bunch of these, it starts to kind of look like a pizza. So the best way to do this is I'm going to be referring to pizza every single time because think of it, this is a pizza slice. So with this central angle that's formed, we have what's called an arc. An arc is an unbroken part of the circle. Basically what you need to think of with an arc, it's the crust on the pizza. It's the crust on the pizza. So if you're looking at this diagram up above, we're going to take another color. So pick up any other color than the one you just used. So I'm going to use pink. This is an arc. That's the pizza crust. This is my crust. This is the slice itself. So that is my arc. Okay, the notation for an arc is you clearly have a start and a stop point for that arc. So this is arc AB. The way you write it is you put an A, you put the B, okay, then you put like a little curvy above it. Not a straight line, it's got to be curvy. And just as with a lot of things when it comes to lines and stuff like that, it could be in any order. So that could be arc AB or BA. Once again, put in like a little mini arc up above it. It refers to the pizza crust. So then we have two different types of arcs. Okay, so this is an arc. There are two different types. So rather than reading all this, which you can do on your own, you just need to know that there are two different types of arc. We have a minor arc and we have a major arc. So go ahead, and then we're going to talk about a semicircle. Go ahead, pause the video real quick, fill this in on your notes. Make sure you put all these points on there. We're going to be referring to them in minor arcs and major arcs. So pause the video for me. So hopefully you paused it and wrote that all down. So first things first, we're going to talk about a minor arc. Okay. A minor arc kind of goes along the lines of an acute angle. Okay. An acute angle was really small, but we're not dealing with 90 degrees. A minor arc has to be less than 180 degrees. So a minor arc is less than 180. Major arc is between 180 and 360 degrees. So remember, arcs are these curvy parts. So I hope we all know that a full circle is 360. Okay, because it's how curvy something is, that's why it is measured in degrees. So a minor arc is less than 180 degrees. A major arc is between 180 and 360. The other reason that it deals with degrees is because, as we saw up above, they are correlated to angles. Okay, so angles are measured in degrees, so are arcs. Arcs are measured in degrees. So go ahead and pick up a color, any color. TQ is what we're going to highlight. This is an example of a minor arc. Okay, TQ is a minor arc, so we're going to put TQ and put a little arc symbol up above it. Sorry if you guys are hearing my dog in the background. So TQ with the arc symbol. Or, once again, it could have been named QT. All right. This has a measure less than 180 degrees. Major arc is greater than 180. So pick up a different color. So I'm going to pick up a different color. Okay. A major arc is going to be greater than it. It's going to be this one. I don't have markers. All I have are pens, so that's why I'm doing it this way. That is a major arc, going from T all the way around, back to Q. Now, what you need to understand is that I can't clearly name that TQ again. Because if I name that TQ, how are you going to tell the difference between the green and the purple? All major arcs have to be named with 3 letters. That's what's going to distinguish the difference between the minor and the major. So because of this one, that's why we have point A right there. This major arc is going to be named TAQ. 3 letters names a major arc. So we could do TAQ or QAT, but our rule of thumb, so go ahead and pick back up your pencil, is major arcs are named with 3 letters. They have to be named with 3 letters. So that is the difference between a minor and a major arc. The next thing, I hope we all kind of know this one, it's a semicircle. It's an arc with endpoints that are a diameter. It's half the circle. It is, I don't know why this isn't written down, 180 degrees. So if we have a circle, this being my center, that being a diameter, then we have, of course, our semicircle. Okay, semicircles, they're named with 2 letters. Nothing fancy because it's not minor and it's not major. It's just kind of its own thing. So, because once again, I've hit that 15-minute limit, I'm going to have to stop this video and you're going to have to move on to part 3.